So, uh, hello everyone. I'm presenting on Green Software Project Management, optimizing performance for environmental sustainability. The software development industry faces a critical challenge. The technologies we build have become significant contributors to global environmental degradation through energy consumption and carbon emissions. This presentation examines how systematic application of green software principles directly reduces environmental impact while improving organizational cost efficiency and competitive positioning. Okay, challenge. The information and communications technology sector currently generates between 1.4 and 3.9% of global carbon emissions, approximately 730 megatons of carbon dioxide equivalent annually. Research projections indicate this will expand to 14% by 2040, um, a dramatic acceleration from the 1.5% baseline in 2007. A single personal computer operating continuously generates approximately one ton of carbon dioxide annually. Multiply this across millions of servers in global data centers, and the scale becomes evident. The fundamental problem is software systems operate at unprecedented scale, consuming substantial computational resources. Yet most organizations have implemented limited environmental measurement or optimization. Opportunity. Significant mitigation opportunities exist. Systematic code optimization can reduce energy consumption by 30 to 50%. When combined with renewable energy resource and infrastructure optimization, comprehensive green software practices achieve carbon reductions of 40 to 85%. Organizations implementing these practices consistently report 40% reductions in operational expenses through lower electricity consumption. This is critical, actually. Environmental sustainability and financial profitability are complementary objectives, not competing priorities. Lower energy consumption simultaneously reduces cost and environmental impact. Uh, implementation strategy. This is divided into part one and part two. Let's go over from part one. Achieving these improvements requires systematic implementation across the software lifecycle. First, establish sustainability as a first-class project requirement. Integrate environmental objectives during requirements analysis alongside functional specifications. Second, implement implement continuous measurement systems to quantify energy consumption and carbon emissions. You cannot improve what you do not measure. Third, evaluate algorithms and programming languages based on energy efficiency. Research demonstrates 30 to 50% energy consumption differences from functionally identical applications. Fourth, make architectural decisions explicitly targeting resource efficiency, recognizing that design decisions create cascading environmental consequences throughout system operation. The part two of implementation strategy. Um, continue with operational practices. Deploy monitoring systems provide sorry, deploy monitoring systems providing continuous visibility into energy and carbon metrics, enabling rapid identification of efficiency opportunities. Execute systematic refactoring based on measurement data to optimize identified inefficiencies. Incorporate sustainability metrics into standard project management practices, tracking environmental performance alongside schedule, budget, and quality. Provide comprehensive training ensuring technical teams possess knowledge and tools to implement green software practices. These eight practices work synergistically, synergistically to create systematic environmental improvement integrated throughout the software development lifecycle. Validated case studies. Evidence from large-scale implementation demonstrates these principles work in environment production. Meta's Luleå data center in Sweden achieved a power usage effectiveness ratio of 1.07 through Nordic climate optimization and energy efficient architecture. The industry average is 2.0. This represents 47% efficiency improvement. Microsoft's Project Natick deployed an underwater data center powered entirely by renewable energy, operating successfully for 2 years within zero human maintenance, demonstrating the viability of radical efficiency through architectural innovation combined with renewable energy integration. These are not theoretical exercises, they are working production systems. So business case and economic justification. Environmental sustainability and financial profitability are complementary objectives. Organizations achieving 40% energy reductions realize equivalent operational cost savings. Implementation investment typically achieves payback within months, with sustained savings continuing throughout system operational lifetime. Additional benefits include competitive advantage. Customers increasingly evaluate vendors based on environmental metrics, talent attraction. So, technical professionals prioritize employer environmental commitment, regulatory positioning, proactive compliance provides strategic advantage and substantial return on investment. McKinsey research demonstrates 300% ROI on um, energy efficiency investments in data center infrastructure. Strategic imperative and call to action. In conclusion, so green software development is not a discretionary initiative. It represents a fundamental competitive um, necessity in contemporary software project management. Organizations establishing sustainability as a strategic priority will capture first advantages and sustain competitive differentiation. I recommend three immediate actions. Begin systematic initiatives, quantifying current environmental impact, integrate sustainability into project governance and decision-making processes, and build efficient systems deliberately by applying the practices outlined above. Uh, so these are the ways we can use in order to keep green software to implement green software development and also keep the carbon emission at less. Thank you. I'm Siraj Pradana. Thank you for your time.